So this is a little bit of a summary of the information for the MATH136 online class. And in this video, I'm going to start discussing some of the information in Module 1. If it's a 16-week class, that's your first week. If you happen to be taking this during the summer, or if it's an 8-week class, that's one of your first modules. And in the book, this information is actually chapters 1, sections 2 and 3. So my goal with these videos is just to give you a quick summary of some of the information covered in the sections. Maybe do a few examples. I know that online math classes, you're basically teaching yourself. So maybe this will help some of you as you're trying to do your homework and eventually take your quiz. So the first thing that's covered, I'll just call it solving quadratic equations. The whole key here is let's just determine what a quadratic equation is. A quadratic equation is when you have your variables squared. Earlier, maybe you've seen problems like this. Here's the variable x. You notice there's no exponents on any of the variables. This is called a linear equation. And if you were to solve this, and by the way, while we're talking solving an equation, basically you want to get x by itself, and in a sense what the solution is trying to find the value for x that makes this equation true. So for instance, if we were going to solve this linear equation, I know most of you know how to solve it. You're going to get all the terms with an x on one side and the numbers on the other. So I'm going to add x to both sides. I'll subtract 1 from both sides. And now to solve this, I want to get x by itself. So I divide both sides by 3. And you get x equals 1, which is your solution. What does that mean? That means if I go back to my original equation and I put in 1 for x, this equation should work. So if I do that, I get 2 plus 1, so I get 3 on the left-hand side, 4 minus 1, 3 on the right-hand side, so this thing checks out. That's called checking your work, or you're checking your solution. So this was a linear equation. What we're going to do now is we're going to start solving quadratic equations. And here, let me just give you a list of, in the course of this little review, some of the equations that we're going to go ahead and solve. So for instance, x squared minus 9 equals 0. The key is, since I have the variable squared, this is a quadratic equation. Another equation, and we actually call this a binomial because there's 2 terms. Bi means 2. Here's an example of an equation solved where we have 3 terms over here. Once again, this is a quadratic equation because the variable is squared. So those are examples of 2 different kinds of quadratic equations. So how do we go about solving these equations? So basically, what we're saying is somehow we want to determine the value or values. There may be more than one solution. We want to determine the values of x that make these equations true. Of course, we work them one at a time. And I would say for the most part, there are two methods that we're going to use, and most of us use, in order to solve quadratic equations. The first one, oftentimes we like to factor. Now in this class, we're going to all assume all of you know how to factor, that you remember how to factor. So in a few minutes, when we solve some of these equations, you're going to see me factor. The thing about factoring does not work for every quadratic equation. There are many quadratic equations that will not factor. So factoring is something to consider, but it doesn't always work. So the second method, maybe if it doesn't factor, maybe you just don't like to factor, the second method always works for every quadratic equation, and that's called using, I'll call it the quadratic formula. In a minute, we'll go through this, and I think when I give you the quadratic formula or the quadratic equation, you'll recognize it and remember it, since you've probably had it before. So let's do this. Let's go ahead and solve some of these equations and see if we can factor. Let's take that first example. Just so you know, I'm not going to write the steps out, but to tell you verbally, if you try and solve an equation by factoring, the first step is to make sure one side equals 0 and everything else is on the other side. In this case, the equation is already in the proper form. I've got a 0 here and x squared minus 9. Now I'm going to take and I'm going to factor this. Now if you remember how to factor, we can perform difference of squares on this. X squared minus 9 factors into x plus 3, x minus 3. And now you notice I'm multiplying these two parentheses. I'm going to call these parentheses factors. Factors in math, factors are things you multiply or divide. In this case, I'm multiplying these two parentheses, so each parenthesis is what I call a factor. And hopefully you realize when you multiply two things together, if either one of these is 0, then the whole thing is 0, and that will be a solution to your equation. Right? Hopefully this is reviewed. So the way I solve this is you take the first parenthesis. Now we can really do this in our head, but just to be clear, I'm going to take the first parenthesis and I'm going to set it equal to 0, and I'm going to solve for x. Normally when you solve this, you would have just looked at this, and if I said what value of x causes the first parenthesis to be 0, you would have said minus 3, and that's one of your solutions. Then you go to the second factor and you do the same thing. You say what value of x causes the second parenthesis to be 0, and you would say 3. So in this case, we actually have two solutions. There are two different values of x that will make that equation true. Therefore, we've solved it. Let's look at the second equation I wrote up here. This is a trinomial because there are three terms. Now just to be clear, I'm actually going to solve this by factoring again, but I don't have to solve by factoring. I could have, and some of you might want to, right away just use the quadratic formula or the quadratic equation. So really the choice is yours. Sometimes factoring is less work if it's easy factoring, but not always. So once again, I don't have time to review factoring, but if you factor this, once again, I need two numbers that multiplied together equal -18, but then when you add them together, equal -3. And as it turns out, I believe -6 and +3, right? Once again, I can't give a lesson on factoring right now. If you multiply out these two parentheses, if you use FOIL, whatever method you use, you will get this right here. So once again, at this point, to find the solution to solve it, it's pretty straightforward. If I look at my first parenthesis, what value of x causes that parenthesis to be 0? It's 6. What value causes this parenthesis to be 0? My second parenthesis, -3. There are my two solutions. If I took the time and plugged 6 in for x, this would work. If I plugged in -3 for x, it would work. So there we go. Let's do another trinomial, and let me show you what oftentimes happens. How about x squared So once again, we're trying to solve this equation. This is a quadratic equation, the variable squared. And say we want to try and factor. We like to factor, we think factoring is easy. So I would look here, and once again, I've got to find two numbers where if I multiply them together, they equal -1. But if I turn around and add those same two numbers together, they equal 5. As it turns out, there are not two numbers that do that. In other words, this does not factor. So you cannot solve this equation by factoring because the trinomial doesn't factor. So we're going to have to use the quadratic formula, or a lot of times people call it the quadratic equation. So here's the basis of a quadratic equation. It's like a formula. Here is the starting point. Say you have some kind of trinomial, quadratic equation. It's like a trinomial. So you got your variable x squared, your variable x. A, B, and C are numbers. A and B we also call coefficients. The number that's in front of a variable is called a coefficient. So this is a standard kind of equation. A, B, and C can be any number. It can be a positive number, it can be a negative number, it can be a fraction, it can be decimal, anything. A, B, and C just have to be any real numbers. So it turns out if we want to solve this equation, there's a formula, which like I said, most of you have probably seen before. This is called the quadratic formula or the quadratic equation. So it's -b plus or minus square root of b squared minus 4ac over 2a. So what happens is you're given a quadratic equation, and all you have to do is figure out what your a and what your b and what your c is, and you plug those into this formula here, and that will give you the solution to your equation. So for our problem, a is whatever is in front of the x squared. Well, there's nothing here, which really means there's a 1 there. It's not a 0. It's 1. B is whatever is in front of the x term. In this case, it's 5. And then C is what we call sort of the number term, or the third term. In this case, it's not 1, it's -1. You have to include the sign. So based upon this, if I plug in my A, B, and C into my formula, then I will have my solution. So negative B. Be very careful. I always go ahead and write the negative first. Before I even go and get the value for B, I put my negative there. So negative B, B is 5, plus or minus B squared, 5 squared, minus 4 times A is 1, times C is -1. All of that over 2 times A, and A is 1. So it's really just a matter of, once you figure out what your A and B and C are, it's the old plug and chug, right? Now it can be sort of messy because we have this square root here. So of course you need to follow order of operations. I'm going to go see if I can figure out what's inside the square root. Of course, I notice 4 times 1 times -1. This whole thing is -4. 5 squared is 25. So we'll have 25 minus a -4. What happens when you subtract a negative? It ends up being like addition, right? So it's really 25 plus 4. So you end up with -5 plus or minus square root of 29 over 2. At this point, this is basically our solution. You know, you always have to check, since you have a square root here, make sure it can't be simplified, but this is already simplified. And this is called, in math, we call this an exact answer. And you can see there are actually two solutions, the plus or minus. When you actually give the answer in your homework, they don't allow you to write it like this. They actually have you write out the solutions one at a time. So say I'll add the square root. So that's my first solution, -5 plus square root over 2. And then my second solution is, then I subtract the square root. So you see there are two solutions. Now there are times where for some reason you may want to know, or someone may ask you for an actual number, like a decimal. So you could grab your calculator. These are exact answers. But if someone wants to know an actual decimal, they want a number, then we can give them an approximate answer. So I'm going to take 29's square root, -5 plus square root of 29, and then divide that by 2. And if I round it maybe to the 10th place, I would have 0.19. Then I do this one over here, 29 square root . So those are two solutions. So this is an example of solving a quadratic equation with the quadratic formula. Now just to note again, if for some reason you don't like to factor, or you forget how to factor, I mean, you need to know how to factor in this class, but for some reason if you don't want to factor, you can always just use this quadratic equation. Now let's talk a little bit more, because in the homework there's one aspect of this quadratic equation which they want you to realize. Now let me take a minute for this problem. In the homework, sometimes they like to ask you about what your solutions are going to be. For this one, and let me make sure I get the exact wording down, because in the homework they use a certain kind of wording. Matter of fact, I have a copy of the homework here. Okay, the choices are, you're going to have some problems where they're going to say, these would be, this is called two unequal real solutions. So basically I have two solutions. Unequal means obviously they're not the same number. Real means it's a number, just like a normal number. We're going to see in a minute where we have some answers that are going to be complex numbers. These are real numbers, and of course they're solutions. So this is an example. When we solve this quadratic equation, we have two solutions, two real numbers. We call this two unequal real solutions. I stress that because the other option you're going to have you will have some quadratic equations to solve, and you will have what they call a repeated real solution, which basically means you just have one solution. A lot of times when we solve a quadratic, you get two solutions. Most of the time you probably get two solutions, but there are certain equations where it's like you get the same solution twice. So in a sense, you only have one solution, and they call it repeated. I'm going to do an example of a problem like this in a minute. So if this is a little confusing, just hang on and you'll understand it. But then there are going to be some quadratic equations we're going to solve, and I'm going to explain to you in a minute where the solution is what we call a complex number. So let me not even talk about this until we get to it. Let me go now, let's solve another quadratic equation, and let's make it one where we get what we call this repeated real solution. So an example of that would be x squared plus 14x. And you notice here I almost always use x's because just most of us in math, if we have a choice, we always make our variable x. I could have used a here or t or s, but x is always what we use. All right, another quadratic equation to solve. Actually, this thing does factor, but just for fun, I'm not going to factor. I'm just going to go ahead and use the quadratic formula. So I know A would be 1, B would be 14, and C would be 49. So negative B, negative 14, plus or minus B squared, 14 squared, minus 4 times A times C, all over 2 times A. Now here, I'm actually going to have to grab my calculator because I don't want to do this in my head. I might make a mistake. So inside, 14 squared is like 196. Subtract 4 times 49. If I do that in my head, it's 160. I think it's 188. Let me make sure. I think it's more, this is why I don't trust my head. Actually 196. See, I would have made a mistake. So really I have 196 minus 196. So really, what I have here is square root of 0. Square root of 0 is 0. So it simplifies down to negative 14 over 2, which is negative 7. Since the plus or minus is plus or minus 0, the plus or minus also goes away. We only have one solution. You know what happens if we were to solve this by factoring? If we factor that, we would have had x plus 7 times x plus 7 equals 0. And I would have had my two solutions for both parentheses are both negative 7. That's why they like to call it a repeated real solution. The solutions is exactly the same for both parentheses. And that's why when you give the answer, of course, you just write the solution once. You don't write it twice. So this is an example. Remember I told you sometimes you'll have a quadratic equation where you solve it and the answer is a repeated real solution. That means there's only one solution. So far, when we're solving quadratic equations, you can have two basically real solutions. Unequal here, we know they're not the same. You can have two real solutions, you have one real solution, or a complex number. I may write that out. Sometimes I like to write things in just simple language. When you solve a quadratic equation, here's what's going to happen. You're going to have two real solutions. You might have one real solution or two complex. We haven't talked about this yet. Here are your possibilities. In the actual homework and on the book, the two real they call two unequal real solutions. The one real they call a repeated real solution, and then the complex. So now let's look at the last thing for this video. Let's look at solving a quadratic equation where it ends up being a complex solution. And we're not going to quite finish it in this lecture, but we're going to get started, and you're going to see what happens. So let's go ahead and solve this equation. Looks pretty simple, straightforward, nice small numbers. X squared plus 2x plus 5 equals 0. We're trying to solve this equation. I was just find the value or values for x that makes this equation true. This does not factor, so I have no choice. I really need to use the quadratic formula. A is 1, B is 2, and C equals 5. So if I apply the quadratic formula, negative B, negative 2, plus or minus square root of B squared, which is 2 squared, minus 4 times A, which is 1, times C, which is 5, all over 2A, 2 times 1. So if I go figure out what's inside my square root, negative 2 plus or minus. So here, 4 times 1 times 5, this is 20. 2 squared is 4. So I already have 4 minus 20. So inside the square root, I have a negative 16. Now let's stop and think about this, because hopefully most of you have learned and remember in math that, you know what, we cannot really take the square root of a negative number. The square root, when you take the square root, you're trying to answer this question. You're saying, what number can I multiply by itself twice equal negative 16? If I have square root of 16, and I ask myself, what number can I multiply by itself twice that would equal 16? I would say 4. Square root of 36, what number multiplied by itself twice equals 36? I would say 6. The problem is, for square root of negative 16, what number can I multiply by itself would equal 16? How about negative 4 times negative 4? Well, the problem is, negative 4 times negative 4 is 16. It's not negative 16. If you think about it, it's actually impossible to multiply the same number by itself and get negative 16, or to ever get a negative number. That's why up until now, that little sign means no solution. Up until now, whenever you end up with a negative under the square root, we would stop and we would say, we're done, problem's over, no solution, we can't do any more math. And that's been the case. However, now, what we're going to do is we're going to learn about what we call complex numbers, where we're not going to stop here anymore. We're going to use what we call an imaginary number to go ahead, even though it's square root of negative 16, we're going to go and do some more math. And I'm going to show you in the next video. So this is the first video for Module 1. There's some more information to be covered in Module 1, but I'm going to put that in the second video instead of making this video too long. So in just a minute, I'll start the second video, which will talk about what do we do with negative numbers under the square root.